So we have this idea that you've seen before, that a set is a collection of things. It can be A is 0, 1, 2. It could be X is the set of positive integers. Notice we said well-defined and causes no logical paradoxes. So well-defined, often we're not dealing with sets of things that are numbers. Does this define a set? Let NBA be the set of all NBA players. Is it well-defined? Can you tell me who is in this set? So is Michael Jordan in this set? How many of you vote yes? How many of you vote no? Okay, so it's not well-defined because 4 people voted yes and 4 people voted no. However you define a set, it has to be well-defined in such a way that there can't be any controversy. So this doesn't work. Not well-defined. Let's try again. I have to be more careful about what I mean here. Let NBA denote all the current NBA players. What do you mean by current? Like at this, like you're on a court at this exact moment? Okay, let NBA sub 2021 denote all the people who played in an NBA game during the 2021 calendar year. Is that well defined? Is that well defined? Can you determine whether or not Michael Jordan is in that set? Remove any ambiguity when you define things. And of course, you could do this with just like a huge list. You could say like NBA equal and then curly brace and then just start listing people with commas and then write curly brace. And that would remove any ambiguity. But you want to compress that a little bit. What about paradoxes? We want to avoid paradoxes. You can't get away with this. The idea of a paradox here is there's some weirdness that can happen when you start talking about the set of all sets or different things. This is going to not be anything that we will run into. If you're curious about it, I would encourage you to seek out Russell's paradox, which is a famous mathematical issue that people ran into when they started talking about sets. Basically, there are issues you can run into when you start thinking about sets. And Russell's paradox eventually led to the creation of what's now called category theory, which you may see at some point, but we will not see ever in this class. So now I have 6 groups. Can we come up with 18 examples of sets? And let's not say the set of all integers. I mean, that's a great set. That works as one. But let's also think about sets that we might encounter in quote unquote the real world. So we can have pure math examples, and real world examples.